Hey everyone, welcome to Chapter 10. In this lesson, we're going to create a graphical user interface, or GUI, for our limrig creator. Before we begin coding this, it's good to draw up an image or anything that we can use to give us a rough idea of the tool we're trying to create using Maya commands. Let me give you some examples. Here's a rough sketch I did. It's not the most beautiful thing in the world, but it helps to visualize the concept I'm going for. Next, I took this into Photoshop and cleaned it up a bit. Now it's actually looking like something that could be used inside of Maya. Going into this, I knew that my tool wouldn't look exactly like what we see here. When you actually get into scripting the UI elements, it may make sense to change things around a little bit. Now that I've actually written this GUI, I'm certain that it looks a little bit different. This is what I ended up with. Before we get started, let's go to the Maya documents and copy some examples directly into our script editor. When creating UIs, the Maya docs will be your best friend. And to be honest, they'll be your best friend for everything. I've been using Maya for about 14 years and have been scripting at least half that time, and I still use the docs constantly. The first example we'll copy over is the window command. We need a window to build our UI. In this example, we see a window with two buttons. If you look at the code, before the buttons are created, there's a column layout command. We use different layouts to organize the elements within our UI. As the name suggests, the column layout arranges the elements in a column. So if we copy over this command and run it, we'll see a couple buttons laid out in a column. Let's take a look at a few more examples, then we'll begin writing our code. The row column layout is one I use quite frequently. It's pretty robust in how we can organize things. Maya gives us 4 different examples on how we can use these. We can use radio buttons when we want the user to choose from one of multiple mutually exclusive options. And we can use checkboxes to represent our Boolean arguments. There are so many more UI commands. We'll take a look at a few of them when writing this tool. After you complete this course, I encourage you to explore some of the others on your own. With an idea in mind, let's start to create our GUI. Again, I'll be scripting this in PyCharm, but you can follow along in any editor. I'll paste in the command to use our lim script here, because we'll be needing it towards the end. Let's also import Maya commands at the top. Let's call our UI function limUI. The first thing we want to do is check to see if a window with the same name exists. Though we haven't defined it yet, our window name will be limCreatorUI. If there's already a window by that name, we must delete it so we don't end up with multiple instances of our GUI. Next, let's actually create that window. The first argument is the name. You can pass this in as a string. We can also give our window a title that will display at the top. Let's define the width at 500 pixels and the height at 540. Then, we'll want to create our main layout. I'll do this with the column layout command and give it the same height and width as our window. I'm going to put a placeholder comment for where I want to add our collapsible frame layouts. We'll try to stay organized by writing these as their own function. The last thing we'll want to add to the limUI function is the show window command. This is how we tell the program to launch our interface. Let's go into Maya and change our import so that it opens our UI instead of running the lim script from the previous chapter. I got an error when I first ran this because I forgot to change the most important part of the import. That is the actual script that we're importing. This script is saved as limui.py, so if I change my import, now it should work. We can run this as many times as we want. It will not create multiple windows. Let's create some functions for the frame layouts. We'll call the first one buildDataFrame. We'll also add an argument for the window and main layout. We'll be using the window argument inside this function a little later on, but for now, we only need the main layout. Next, let's create a variable called DataFrame. In it, we will create our frame layout. I like to define all my UI elements in a variable, even if we're not going to be calling them elsewhere. We can give this a label, buildData, then we can set the width and height of the frame. We want it to be collapsible, so we'll set that argument to true. Using the parent argument, we can attach this layout to the main layout that we created in the previous function. I'll copy this function and paste it below. Then I'll change the function name, arguments, and values to represent what we want for the build arguments frame. I'll do this one more time for the color settings frame as well. Then go to our main function and add the frames in using the 3 functions we just created. Now if we go into Maya and run our UI command, we can see our frame layouts have been added. They don't really collapse or do that much of anything yet, so let's keep going. Let's populate our build data frame. First we'll need to build a layout. I'll choose to use a row column layout with 3 columns. We'll set the width of the first 2 columns to 200. This will be for our text fields, and and the third column to 100 for our button. We can set some column offsets as well. The first argument is the column index. The second is the attachment. You can use left, right, or both. And the third argument is the offset. Then let's parent this to our frame layout. Next, let's create 3 text objects that will act as the label for our column. We'll want one for alias, guide, and load. We can align them to the left and even choose a bold font. There aren't that many fonts to choose from, but you can take a look in the docs to see what's available. Next, we'll want to create our text fields, one for the alias and one for the guide. Using the text argument, I'll set a default value for the aliases associated with an arm. I'll leave the guide empty. Eventually, we'll be populating that with a load button to the side of it. And next, we'll create that button with a label called load selected. Remember, we're parenting all these elements to the row column layout. Also, we're creating them in the order we want them shown. We'll do this 3 more times. When we get to the pull vector alias, we'll want to set the enable flag to false. We actually don't need an alias for this, but I felt adding a text field there was more aesthetically pleasing than leaving it empty. Let's copy the text commands from above and modify them with the side, part, and base names. We'll also give it a different font and height. I'll also scroll back up here and add a height argument for the previous text commands. We'll add 3 text fields under these labels. Let's disable the base name text field using the same argument we used to disable the pull vector alias. In the next lesson, we'll add a command that updates the text shown here whenever we change the side or part to fields. Let's go into Maya and see what we get here. It looks like all the build data elements have been added. Again, nothing is functional, but we'll get to that soon enough. Let's move on to populate the build argument frame. I'll start out by making 2 row column layouts. For the first one, I'm actually just going to use 1 column. Having this may seem a little redundant, but it prevented a bug when adding a collapse command later on, so I left it in here. For the second row column layout, I will use 4 columns. The first column, with our label, will be a little bit longer than the other 3. They'll have even column offsets, and we'll parent this to the first row column layout. Then let's add our text label for the primary axis to the first column. Next, we'll want to add our radio buttons. To do this, we need to create a radio collection and tell it the total number of radio buttons we will be providing. Then, we can create an X, Y, and Z radio button. They'll be inserted into column 2, 3, and 4. Now we want to add radio buttons for the negative axis. However, we don't want them to go into the first column. To prevent that from happening, we can add a separator with the style set to none. Then we can copy and paste our positive radio buttons and name them a little bit differently to reflect their negative values. We can use the radio collection command with the edit argument set to true to change the value. Basically, we're setting the default value to X here. Then I'm changing the style on this next separator and parenting it to the first row column layout so that we get a line which stretches across our GUI. Let's copy and paste the second row column layout so we don't have to retype it. We'll modify this so we can use it for our up axis. We'll repurpose the text and radio commands just like we did for the layout. Next, we'll create a grid layout with 2 columns and parent it to our first row column layout. Grid layouts are nice because they're evenly spaced. We'll be adding our checkboxes to this one. Let's go ahead and create those next. We can do this with the checkbox command. We'll give them a label and set the value equal to true so they're on by default. Time to test this out. Once again, we can run our command in the Maya script editor to launch the UI. Here you can see our radio button collections, our separators, and our checkboxes. Now onto the color settings frame. Yet again, we'll add a row column layout. Nothing unusual about this. I did notice, however, that the height value in our setup here actually doesn't matter. It's just using the default. And on this one, we'll set up 2 evenly spaced columns. Next, we'll make our color slider group. We can give the first one a label for primary. Then, we'll set the adjustable column equal to 3. This means our third item in the slider, which is the slider bar itself, will be adjustable. These columns are contained in the slider group. We'll align the text to the right, and the swatch to the left, and the slider to the left as well. Here we can also set the default color value and, of course, we'll want to parent it to our row column layout. Let's copy this command 3 more times and change the label, variable name, and color to configure our default settings for the sliders. We're now ready to check this out by running our command in Maya. We see there are 4 color sliders that we can play around with. To wrap up this lesson, let's add some buttons at the bottom of our UI. We'll create a function called buttonGrid and pass in the window and main layout as arguments. Go ahead and make a row column layout with just one column and parent it to the main layout. This is basically just padding. Then let's create another grid layout for our buttons to go in. We'll just use 2 columns for our 2 buttons. The width will be 50 and the height will be 40. Then parent this to the row column layout above. We can make 2 buttons with a height of 40, one to build the limb and one to close the UI. And last, let's add this button grid function to our main limb function above. One of many nice things about PyCharm is that it will catch a lot of errors before they even have a chance to make their way into Maya. Let's go ahead and run this to make sure our buttons have been added. Excellent. We've just designed the UI for our limb script. In the next lesson, we'll build the functionality. Thanks for watching, and I will see you in the final lesson of this series. Hello and welcome to the final lesson of this tutorial series. Congratulations on making it this far. Or if you're just tuning in for the lessons on creating a GUI, that's okay too. I'm happy to have you with us. Let's launch our GUI we just created in the last lesson and take a look at what we have so far. In this lesson, we'll add some functionality. There are a few things we want our GUI to do. When we click on these buttons, we want them to load the selected object into the adjacent text field. We want to add a change command so when we change the side or part naming, the proper base name is displayed here. When we collapse or expand these frames, we want our window's size to be adjusted. When we hit build limb, we want to build our limb based off the provided arguments in the GUI. And of course, when we hit close, we want the GUI to close. Let's start with loading selected objects to the GUI. It's a pretty simple one. We can write a function called loadCell. We'll just pass in the text field as the argument. Next, we'll list our selection. Then, check to see if anything is selected. If it is, we can use the text field command to edit the text field that we pass in as our argument. With edit, we can update the text field with the name of the first selected object. Then we can add this function to all the buttons as a command. For some reason, Maya doesn't like it if you pass in a command with arguments. However, there is a workaround. All you have to do is pass in the argument through lambda like I'm doing here. Inside the loadCell function, we want to pass in the variable name of the text field we want to associate with this button. Let's go ahead and do this for all of our buttons. Now if we launch our GUI, we're able to populate our guide text fields using the load selected buttons on the right. Let's do another simple one. Let's add the change command for the base name text field. So go ahead and create a function called change base name. We'll pass in the last 3 text fields into this. Next, we'll want to query the text that is in the side and part text field when we run the command. Then, we'll use the text field command to edit our base text with the new side and part value. Now, just after the text fields are defined, let's go ahead and update the side and part text objects using the text field command in edit mode. What we're doing is adding a change command. The change command is the function we just wrote. Again, we'll need to pass this through lambda to work. And let's just go back to the change base name function and make sure I didn't type anything incorrectly. And of course I did. This should say edit instead of exit. Now let's run our GUI. When we change the side or part text, the base name text is updated. Let's go ahead and make our collapse and expand command for our frame layouts. I've written these as 2 separate commands, but I suppose we could just write it as one and add an extra argument to determine whether you're expanding or collapsing. Whatever works. I've called my first function collapse command with the arguments window, frame layout, and height. Next, let's query the window height and the frame layout height and store them in a variable. Then we can edit the window and frame layout with their height variables respectively. If we're collapsing, we'll want to take the height value we queried and subtract the height value we pass in. Then we'll add 25. 25 pixels is roughly the value of the frame's text bar. Let's go ahead and duplicate this function and rename it to expand the command. Then swap out our operations so we're adding the height and subtracting 25. Now we can use these functions inside of each of our frame layouts. I'll go up to the data frame and, using lambda, I'll append our collapse function to the collapse command argument. We can pass in the window, the data frame, and the height value. Then, while still inside the frame layout, let's add the expand command the same way we added the collapse command. Let's now do this for the other two frame layouts. We can copy these two commands and just change the frame name and height. One more time, let's launch our GUI to test these changes. If all goes well, we should be able to expand and collapse our frames while changing the height of our entire UI. The last thing to do is write our command to build the limb. To do this, there's a fair bit of data we need to gather from the frame functions. Like I mentioned in the previous chapter, if we were using classes, there would be less juggling of arguments between functions. In the course materials for this chapter, I will also include a version of this script I've written as a class. Let's build a dictionary at the end of this function and return the UI elements we'll want to query in our limb command. I'll take the side text field, the part, all three joints and their aliases, and the pull vector. Then we'll return all this information. We'll scroll down to the arguments frame and return the primary and up-axis radio collection, as well as the checkboxes for add stretch and remove guides. Next, we'll want to return all our color sliders in the dictionary as well. Because our frame layout functions now return a dictionary, let's go into our limUI function and assign them to a variable. Let's copy the first dictionary over to a new one called commanddict, then update the commanddict with the two other dictionaries. This will leave us with one long dictionary of UI elements that we can pass into a function. We'll also want to pass this dictionary into our button grid function. So we'll add that down here as well. Then we'll write the command to build our limb. Let's call this build limb command and pass in the commanddict here as well. Next, let's define the side, part, and pull vector by querying their text field values. We can find their UI object by using the keys we set up in the dictionary. For the alias and joint lists, we can loop through their keys in the dictionary and create a new list. Each time through the loop, we query their text field value and append it to their list. Let's query the checkbox values for remove guides and add stretch as well. To query the radio button's value, we first need to query the radio collection to find out which one is selected. Then we can query the result of that to find out what the label is. For the color values, we can query the color slider group's RGB value. Let's do this for each one. We'll then create a new dictionary called colordict. For this, we'll use the same side part naming we used to tag our controls in the previous chapter, and we'll use this for the keys. For the value, we'll use the result of our query. Next, let's pass in all these variables we just defined into our limrig script as the arguments. The last thing to do is pass this function into the command on our build button. We can also add the delete UI command to the close button. And with that, I think we're pretty much done. Let's go into Maya and test this thing out. Using load selected, we can go down our arm guides and add them into the GUI. For the left arm, we can just use the defaults. Let's go ahead and do the same thing on the right side. We can change the FK, secondary, and pull vector colors to something slightly more red. I forgot to change my primary and secondary axis to negative for the right side. Fortunately for us, this script is undoable, so let's undo and try again. And that's all, folks. Thank you so much for joining me on this scripting journey. I hope you enjoyed watching and learned a thing or two. I look forward to seeing all the cool stuff you make with this knowledge. Best of luck in all your future rigging and Python endeavors.